Now we take the next formula, that is 7. Find the derivative of cos x. Find the derivative of cos x with respect to x from first principles. Now let y is equal to cos x. Let delta x be a small change in x and delta y be the corresponding change in y. As usual, we do like this. So we write here y plus delta y is equal to cos of x plus delta x. Below that you write y is equal to cos x and subtract as usual delta y is equal to this is what cos of x plus delta x minus cos x. Divide both sides by delta x and take limits as delta x tending to 0. So normally we just first of all divide, then divide both sides by delta x. Cos of x plus delta x minus cos x by delta x. Now write limit delta x tending to 0 and here also limit delta x tending to 0. This is what as usual we write symbolic notation dy by dx is equal to this limit we have to evaluate. Cos c minus cos d formula we use it, that is minus 2 sin c plus d by 2. C is what? X plus delta x. D is what? X. Minus 2 sin c plus d by 2. X plus delta x plus x by 2 into sin c minus d by 2. X plus delta x minus x by 2. This x and x cancels and whole divided by delta x is there. Now this becomes, here in this step you see we have to manipulate and write as into a formula sin x plus delta x plus x by 2 means what? 2x plus delta x whole divided by 2. Then we write in a big bracket here sin delta x by 2 is there. Sin delta x by 2 by delta x is already there, so the delta x, the numerator 2 was there. That 2 you bring it below this and leaving behind that minus sign there only. So this is equal to, this is in the form why we are written like this, sin theta by theta, theta to 0 is 1. So minus sin, wherever delta x is there you write 0. 2x plus 0 by 2 into 1. Why 1 here? Since limit sin theta by theta, sin theta by theta, theta tended to 0 is equal to 1. Because of that we get it. This 2 and this 2 cancels. So it is equal to minus sin x. So if y is equal to cos x, dy by dx is equal to minus sin x. Here this is not there, so we remove that. we take the eighth formula, find the differentiation of tan x with respect to x from first principles. First principles is what? From the definition. So let y is equal to tan x, and then let delta x be a small change in x, and delta y be the corresponding change in y. So wherever x is there, x plus delta x, wherever y is there, y plus delta y. Y plus delta y is equal to tan x plus delta x. Same method, y is equal to tan x, we write, then subtract delta y is equal to tan x plus delta x minus tan x, and divide both sides by delta x and take limits as delta x tending to 0. So simply we write delta y by delta x here, and that means I am dividing both sides by delta x, tan x plus delta x minus tan x whole divided by delta x, and here take limit delta x tending to 0, here also limit delta x tending to 0. This delta y by delta x limit delta x tending to 0 is what? Simply dy by dx. Now right hand side, this is a problem in limits which is to be evaluated. So that directly it will be in the form 0 by 0. So what we do? We write tan as sin by cos. Sin x plus delta x by cos x plus delta x minus tan x is written as sin x by cos x whole divided by delta x. Now this is equal to, take LCM, then we get sin x plus delta x into cos x minus cos x plus delta x into sin x. That LCM along with the delta x we write together here in the denominator. Delta x into cos x plus delta x into cos x. So now numerator is in the form sin a cos b minus cos a sin b, sin a minus b. Limit delta x tending to 0, sin x plus delta x minus x whole divided by delta x into cos of x plus delta x into cos x. Here x and x cancel. So put it in the form, let delta x tending to 0, sin delta x by delta x into the other thing you keep here, cos of x plus delta x into cos x. So here sin theta by theta, theta tending to 0 is 1. So it is what? 1 into 1 by cos x plus 0 into cos x, which is equal to 1 by cos squared x, which is equal to secant squared x. Therefore conclude it. Therefore if y is equal to tan x, dy by dx is equal to secant squared x.